All right, 2.5, notes solving rational equations. So the first part, we're just going to review first on rational expressions. So when we talk about a rational expression, that is a polynomial divided by a polynomial. Okay, so examples would be such as 2x is a polynomial. 3x minus 1 is a polynomial. 5 is a polynomial. X squared minus x plus 1. These are all examples of polynomials. And so what we're going to do here is look at why we can simplify a fraction. Why do we get 24/9 and it can reduce down to that 8/3? Like, how do we get to go from here to this here? Okay. You look at this problem, more than likely you've learned, okay, I can reduce the top and bottom by 3 and I'll wind up with 8/3. But that's just the process. But why does it work? So let's just look at it. What I'm going to do is I'm going to take 24/9 and I'm going to break it up. And so I'm going to take 24, and that's going to give me 8 times 3. And in the denominator, I'll have 3 times 3. Haven't done anything mathematically wrong. Now, if I equal that out, what I'm going to do this time is I'm going to separate these two fractions that I have here. And it doesn't change, again, my answer. Doesn't change what I have. Everything is true. So far, everything I've done is true mathematically. But we know that this right here equals a specific number. Anything over itself is 1. You can say 3 divided by 3, and that is 1. Okay, so I'm going to rewrite this again, and this time if I have 8/3, but I'm multiplying it now by 1. And then 8/3 times 1 gives me this 8/3 here at the end. So that's why it works. Now, we wouldn't do that with every problem, but that's what we're doing. So what I want to talk about is that, why can I do that? But why am I allowed to do that? Okay, so the first thing I want to think about is that we can cancel things out if we are doing that in a form of 1. Okay, and a little note here. Okay, we can cancel something, fraction, whatever we want to call it, that equals 1 because multiplying by 1 does not change your problem. Does not change your problem. All it's doing is just rearranging what it looks like. And we do that all the time. We manipulate it so that we can change what it looks like so we can do something better with that. Okay? Now the thing is, though, if you add 1, that changes your problem. Okay, so we don't want to, when we're reducing or anything like what we've done so far, is that we're just changing it. We're not trying to change the value of anything, so we just know that that's what's going to happen with that one. Okay. So now, based on what we just did above here, what I've done up here, which of the following illustrates this principle? So I'm going to go through each one. So if I look at the first one, I have a form of 1. Okay, if I have a form of 1, if I have something in form of 1, then I'm allowed to cancel it out. Well, right here, we have a form of 1 right here. 3 over 3, okay? And these are being multiplied together. I'm not adding anything to it. The 3 over 3 is not being added to these other ones. So this cancels out. So this actually right here, it does work, okay? All right. Now this one right here, it looks like it could be, but I am not multiplying 3 times x and 3 times y. I'm adding, and when I add, that changes my problem. Okay, these belong together. They're not allowed to be separated. So therefore, this is not something that illustrates the principle from above. Okay, so the third one, it looks a lot like, there's got a multiplying. I mean, it could look like this in a way, but because I have things being multiplied together like this, here is my former 1. So that's my former 1. That can cancel, and therefore I can actually reduce and simplify it based on our principle. Now again, the last one does look a lot like that, the one we just did. I have this right here, x plus 1 is x plus 1, but I'm not multiplying. That top has this plus 2. That plus 2 is not being multiplied to the 3 times x plus 1. It's being added. So that's going to change the problem. So I cannot apply that to this rule. That principle, this does not apply to that principle. So let's go over a few things to kind of remember. One thing we know that we cannot do, you can never, 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 never cancel terms. Okay? Terms. What are terms? Terms are things being added or subtracted. We can never cancel those out, okay? All right, so that's what terms are, all right? And then you can only cancel factors, okay? And what are factors? All right, things being multiplied. So when we look at each of the following things we're going to do here, we're going to talk about how, when we can reduce them or simplify them or not, okay? So we're going to go through this all review of our rational expressions and then go to solving. So let's look at each of these down here, 1 through 3. We'll start with number 1, and we're going to look at what we have, okay? I want to know, can I simplify these? Can I cancel? Yes or no? And I can cancel because the only thing that I see between them are multiplication. There is no factoring happening, so therefore it is okay to cancel. So if I look with the numbers first, I'm going to divide 3 by 3, get a 1, and 12 divided by 3 is a 4. So I know here in the denominator, I have a 4. And I'll look at the x's. Now, there's a 2 up here and a 1. If I subtract the 2, it's positive. So 2 minus 1 is 1, so I have 1x. Man. And then the last one we have is the y's. It's 1 minus 2, which gives me a -1, so the y goes here. Okay, so this has been simplified as far as you can go. Number 2, these are not factors because we have a minus and a minus separating them, okay? Cannot have that. So what we're going to do first is there are a couple things you want to look at when we do these things. We kind of review. The first thing you want to do is that you must have factors. You must create factors, okay? Must have factors. That's the only way you're going to simplify. So in order to have those factors, okay, you're going to have to factor, or let's look at the word create because it makes it, we're going to create factors, okay? And we'll talk about that. Okay, and how, so, or you can say factor terms and factors, and so that gets a lot of that word going on. So the first thing we want to do is just factor out what we can. What's the GCF? I'm going to put on there. Think of GCFs, okay? Think of GCF. So if I look at the numerator, the GCF that I have for these 2 problems here, this 2 terms here is 3. factor out a 3, I wind up with a 2 minus k. Down at the bottom is a difference of squares, so I'm going to have a k minus 2 and a k plus 2. Now I can I can cancel if they're exactly the same. Now these are not exactly the same. This one looks a lot like this one, but it does not. You cannot cancel them, so I'm going to go off to the side here and look at how do I make it? Can I make it look like that? Let's see. So I'm going to off to the side here, I'm going to write that 2 minus k is the same as negative k plus 2. I just rearranged it and went back and forth. Okay, I still do not look like this k minus 2 down here. I have a negative k plus 2. But I want k to be positive. That might help. So I can factor out a negative. Okay, so if I factor out a negative, which is the same as multiplying or dividing by a negative 1, that leaves me a positive k and a minus 2. So now that looks like that. So what I'm going to do is I'm going to replace this with that one that we just created. Now what I want to do is make sure that we're okay with how we write it so that we don't make any kind of weird mistakes. So I'm going to write our new one in blue. Okay, so the numerator is going to be, I'm going to put the negative here, and then the k minus 2 here. The reason I separated that is because I don't want to write 3 minus k minus 2 because I don't want to make the mistake of thinking it's a subtraction. This right here in front will also, it's just more easier to look at. Okay, now I do have something the same. I have this the same and this the same. So now I can just put negative 3 on top, k plus 2. Okay, and there's your solution. There it is, simplified. Okay, number 3. I see this over and over and over, and you're not ever going to do this, but when students kind of jump to the trinomials here, is they see these p squares here and they just want to cancel like that. And we can't do that because they are not factors, they're terms. They're all being separated by pluses and minuses. So now again, first thing you want to do is to factor each of these. So I'm going to factor this into 2 parentheses. I wind up with 2p. This factoring never goes away. I have a 2p, I'm going to put minus 1 and a p plus 4. So, okay, divided by, only thing I can pull on the bottom is a 5p, and that leaves me with p plus 4. And then, you know, sometimes you factor and then you cannot reduce anything, but hopefully you can when you do these. So now I notice that I can factor out these, cancel those out, so I'm left with 2p minus 1 over 5p. When you are rewriting these, I need you to write them to where I can see your answer, box them in, make them clearer. All right, so now let's review multiplying rational expressions. Now here, since these are all multiplication, they're all factors, there's no adding, subtracting in between any of these, I can just cancel like crazy. So let's cancel out, we can. I like to preferably do it all like this instead of multiplying out, so I'm going to deal with my numbers first. 15 and 5 reduced to a 1 and a 3. Okay, 7 and 14 reduced to 7 goes to 1, and 14 divided by 7 is 2. And my last one is this a over this a squared of that one. So 2 minus 1 leaves me with just an a, and that is up here. So in the numerator I have this 3 times a, and the denominator I have a 2. So again, we did not have to do anything. We didn't have to create factors because it's already factored. They're just all factors there. Okay. Okay. Number 5, a little different. I have pluses and minuses between here, so I cannot just start canceling. First, always want to is to factor. Okay. This right here, I'm going to move over here, so it's x difference of squares, so x minus 5, x plus 5. On the bottom, I can pull out a 2, and I get an x plus 5. My other fraction is just a 10. Now, this x minus 5 looks like it could cancel with this one if we move it when we do it, but again, it doesn't look like that. It doesn't look like that, so I'm going to have to create it, okay? So again, I take it out, and let's just do this one more time. I take, this is the same as negative x plus 5, and if I take out a negative, it looks like that. So over here, I can write negative x minus 5. Next step is to cancel. So let's see what we can cancel. I can cancel x minus 5 with this x minus 5. I can cancel these two right here, x plus 5 and x plus 5. And I can also reduce that 2 and 10. So 2 divided by 10 is 1. 10 divided by 2 is 5. So I have a 5 up here. Look what else I have. I have a negative. So this is just negative 5. Okay, the next one we're going to do, now we're dividing. We did multiplying, simplifying, now we're going to divide. So when we divide fractions, remember you keep the first fraction the same, and then you multiply by the reciprocal, okay? So if I write that, I'll have this one stays the same, and then I'm going to multiply by the reciprocal of this second fraction. Now, the mnemonic that you probably remember, most people will say it when they're dividing by fractions, is keep, change, flip. I like to use, I don't really like to use that terminology as much because I want you to use the math terms. So you're multiplying by the reciprocal. That's what the change is, and the flip is the reciprocal. So now I'm going to have to see if I can cancel. Again, I have that one little thing where this looks like this, but I have to take out and make it a negative. So I'm going to change it to negative t minus 2 over 8 times 6 over t minus 2. Okay, cancel now. We can cancel this one with this one. The 8 and 6 can reduce. So this reduces to divide by 2, we get a 4. Divide this by 2, we get a 3. So don't forget we have a negative here, so we wind up with negative 3 over 4. All right, number 7. Number 7, big stuff, that's okay. And we can handle this. It's just trinomials, 3 terms, and then we have 2 terms over there. So the first thing we should always do is to flip first. You don't want to factor. Usually what happens after we factor, we automatically start canceling. So it's in your best interest to just flip first, okay? So I'm going to keep this one the same. I'm going to flip the second fraction. I'm going to multiply by that reciprocal. So I multiplied, now the reciprocal of this fraction over here is underneath. Okay, so now next step is to factor. So factor, and then I'm going to stop the video and come back and check your work. Okay, so I factored this. Now I'm just going to go ahead and cancel what I can. I have a 2x plus 1 that I can do. I have a 2x plus 3. And that is all. So on top in the numerator, I have an x minus 1 times an x minus 1. Denominator, I have x plus 1 times 2x minus 1. And that's all we can do. Okay, number 8 is not, there's nothing any different than number 8 than what we saw before. It's just the way it's written. It's considered a complex fraction. So, but if I rewrite this as 10x minus, or x minus 3. So I'm saying this fraction is being divided by this fraction. This is what it's written. That's really what you're doing. And it's the same thing as all the other ones. So again, we're going to keep the first fraction and then multiply by the reciprocal. Okay. okay? So I want you to do the work and come back and see what you get. Okay, so I flipped it, factored out a 2, reduced, simplified whatever I can, and my final answer was 4. Okay, for number 9, I'm going to sit here. I'm going to separate this out first. And you might be all ready to just go ahead and, you know, flip it over before and change it right away. But I just want to make sure everyone understands what we've done. This number right here by number 9, sorry, by the way, is a typo. This should be 12. Okay. And so, right over here, now I have x squared minus 100. X plus 3 times, I'm going to flip it over, divided by, this is multiplication. Okay, so now go ahead and I'm going to stop the video, you do the math, and we'll check your work. Okay, so I'm just going to start the video here. I've factored everything. I had this one right here that looked like it could be something that's could be canceled with something else, so I need to make sure I pulled out that negative. So now I can factor this with this, and this one with this one. And I am left with x plus 10 times x plus 4. And numerator, excuse me, that's the numerator, but the denominator I have this negative. And so it's just going to go out here in the front. Okay, that's the same thing. All right. Okay, so we've done multiplying, dividing, simplifying. Now we're going to do adding and subtraction of rational expressions. Okay, so the first thing you want to do when you are having to do this, you must find a common denominator when you're adding and subtracting. It's the only time that you have to do that. So first, change denominators into common denominators. Multiply the top and the bottom by any missing factors. Excuse me. And then add or subtract, then simplify. Okay. Now when we start doing these, there's certain things I'm going to have you do. So starting here, you must tell me what the LCD is. You're going to state it every single time. Okay. I don't care how simple it is or how hard. So the first thing you want to do is, what is the LCD between 3 and 9? All right, our LCD is 9. And now we're supposed to multiply the top and the bottom by whatever the missing factors that you need. Well, for this one, I need a 3, and I do the top and bottom. And there's that form of 1. And here, I don't need anything for the second fraction, so we just leave it. So my common denominator, my LCD, is a 9, but on top I have 3 plus 5, and so my final answer is 8 over 9. Okay. Number 2. Again, 2 things I want. All right, number 2. What is the LCD? Well, the LCD between 3 and 2 is 6. So I'm going to multiply everything, each thing by what it needs. So this needs a factor of 2, the top and the bottom. And over here it needs a 3. So on the bottom I have a 6. On the top here I have 2x plus 6x. And that's going to give me an 8x over 6. And then when I do reduce that fraction, I wind up with 4x divided by 3. Okay. Now again, I want to see the LCD as well as the answer. Number 3. Number 3 is a little bit different. We just have variables. No numbers are there. So we want to find the LCD first. And the LCD between, when it comes to variables, is the way you want to think about it. Everything that you see in the denominator must be in that LCD, okay? So the first thing I look at is I look at the x's. Here's an x and here's an x squared. Well, I need the higher of those two exponents, so it has to be an x squared. And so when I look at y cubed and y, I need y cubed. So my LCD is x squared times y cubed. Okay, so I'm going to put this as my LCD. Now I'm going to multiply what I need. So here I just need, I have the cube and I only have one x, so I got to multiply top and bottom by an x. Here I have to be a y cubed, so I need a y squared times a y squared. So the numerator, you have 12x minus 2y squared. And we're going to always simplify, so you're going to factor it out. You may think, there's nothing that's going to happen, but we're always going to do that no matter what. So the numerator, I can factor out a 2, and I wind up with 6x minus y squared being divided by x squared y cubed. Nothing else more I can do, but we're going to simplify it as far as we can go. All right, starting with number 4. Okay, so first thing we want to do is find the LCD. Okay, when you find the LCD, the thing is about the LCD here is you want to be careful that you look at carefully for each thing. Because they have this and it's not factored, it makes it kind of hard to know, is that y in there, okay? So what you want to do first is factor out, okay? Factor if you can, in which you can see exactly what you need. So if I factor on a y, I get y minus 5 in parentheses. Now I can definitely tell that this y is definitely part of my LCD, okay? And then I also need this y minus 5. It also makes it easier when it comes to figure out what do I actually need to multiply by, those factors for that's missing. So for this one here, I'm not missing any of these, so I don't need to do anything with that. So I'm going to put y times y minus 5 here, and I'm just going to leave this 6y minus 4 here. Now over here, the second one, I have a y, but I don't have the y minus 5. And you need to be very careful. I recommend that you always, when you see a binomial like this, that you put it in parentheses. And hopefully putting it in parentheses helps you to understand that I have a binomial times a binomial, which means I need a FOIL to get a trinomial, okay? Now, the one thing nice about this, different ways you can do this. If you go offside and you want to FOIL this, you can. One thing I want to show you is that you can just do the math and stick it up here in the top, okay? So I'm just doing a different color so you can see what I'm actually doing. So y times y is y squared. Y times a negative 5 is a negative 5y. Y times 1 is a positive y. And then we have 1 times a negative 5 minus 5. I didn't really combine like terms like we're used to doing when we're foiling out because it's all going to be in the top, and I'm going to simplify everything together, whichever way you want to do it. Okay, so now I'm just going to combine like terms. I always do in descending order, so like a trinomial. So this is going to be my first one. So I do have a y squared, and I'm going to cancel that out. Next I have is a 6y minus 5y, which is 1y. Then I add another y, which gives me 2 y's. And then my last one, I have a 4, and a negative 4 and a negative 5, which gives me a negative 9. I don't know why I wrote that. Let's write in the same color as the other one. So this is y squared all over y times y minus 5. And there's nothing else you can do with this. Okay? All right, number 5, we want the LCD first. Okay? So my LCD for both of these is just what I see. There's nothing need to be factored. So the LCD for here is y plus 1 times y minus 1. Okay? Now multiply top and bottom by what you need. So when we're doing math as we go along and start having to write a lot, I'm just do a few shortcuts you're gonna see in some notes, but I'm just gonna write LCD for now, and because it's not really changing, only the numerator's changing, and I will put it in at the very end. So again, find the LCD, and now let's multiply by what we need. Here you need to multiply this by the missing one factor, which is y minus 1. This one is being multiplied by a y plus 1. Okay, now I'm going to make sure I'm very careful. You have to pay attention to what's happening here. I am subtracting, okay? I am subtracting the second fraction from the first. So that whole entire thing is being subtracted. So if you need to be very careful and understand that this whole thing, no matter what you do when you get done, is being subtracted. Okay, so we'll see what that means when we try to go and combine like terms. So I'm going to do FOIL over here like you're used to knowing how to FOIL. So this right here is y squared, excuse me, I'm going to have 7y squared minus 6y minus 1. Okay. And then the other one, so I'm going to put my subtraction here. This one I'm going to put in parentheses. I'm going to just right here, a minus, and then I'm going to FOIL the top. Y times y is y squared. That's a positive y minus 5y, which is a minus 4y. Negative 5 times that is a negative 5. Okay. Okay, because I'm subtracting this whole thing, it changes all the signs. So I'm just going to rewrite it for sake of making sure we can see what we have. We have y squared minus 6y minus 1. Well, negative distributed to everything in here just changes all the signs. So that becomes a positive a negative y squared. A positive 4y, and a positive 5, all over my LCD. Okay, so now combine like terms, and then see if there's anything you can simplify. I'm just going to draw it over here. Okay, so what I'm going to do is combine my like terms. So I have 7y squared minus y squared is a positive 6y squared. And then now I have negative 6y plus 4y gives me a negative 2y. And then lastly, negative 1 plus 5 gives me a positive 4. And now I'm going to write my LCD. You don't get to leave the words, but you have to put that in. But you want to make sure that you have simplified. So I see that I can factor out a 2. And again, when you do that, you have a tendency to say, not a tendency, you may see that you can actually factor that numerator some more and then be able to cancel with the bottom maybe. And the top is not factorable, so that's your final answer. Okay, number 6. Again, state the LCD. So between 5 and 10, it's 10. I need the x squared because it's larger than x. And the exponent's larger for the y squared. LCD. Multiply everything by the LCD, multiply by what you're missing. So the first one, I'm here. I need to multiply that by a 2 and just a y. Okay, over here, I need to multiply just by an x. Okay, so simplify and then combine like terms and see what you get. Okay, so right now I have this. So I need to factor if I can. So in the numerator I can factor out 6. So I will factor out a 6. I'm left with 2y plus 3x all over 10x squared y squared. Now these two numbers can be simplified on the outside here. So we're going to reduce those by 2, and we will be left with 3 here, 2y plus 3x, and down here just a 5x squared, y squared. Again, LCD is needed, as well as the final answer. Number 7. All right, I'm going to state the LCD, and then I'm going to pause and come back and see what our final result is. All right, the LCD between these two is what we see. They're binomials, so they're being multiplied together. Okay, so now we're going to multiply by what we need. So remember here you need a c minus 2, and on top you need a c minus 2. We can see that. Here we need a c plus 2 and a c plus 2. Caution, caution, caution. Right here we have a minus sign. Okay, so I'm going to stop the video, come back and see how you do. Okay, so over here, if you notice, this one I thought was really easier when it comes to distributing, because if I had that negative 3c, I was able just to distribute like that. So combine like terms. Notice that here I pulled out a negative, right here, a negative c and not just a c, mostly because we like that variable here to be positive in its beginning there. Okay, let's go to number 8. Number 8, the first thing we want to do is find that LCD. Can't find the LCD if we have, unless we have factored. So let's factor the denominators, and we will factor, and we get, pull an x, we get x minus 3. Pull out a 3, we get x minus 3. Okay, so now our LCD, again, your LCD must have everything in these denominators that you have, that you need. Sorry, you must have everything in the denominator for your LCD. So let's just start. We have an x. Because it's here, I have to have an x minus 3 from this first one. X minus 3 is in the second one, but I don't need to repeat it. And the next one we have is a 3. And we usually put the number in front. So our LCD is 3x times x minus 3. Okay. So now we're going to multiply top and bottom by what we need. Okay. So if we look at this first one, we do not need anything but a 3. So you're going to multiply this by a 3 and this by a 3. And over here, what we need over here is just the x. Okay. So what I have here will be 12 minus 6x, and I'm going to put that over the LCD, 3x times x minus 3. Simplify, okay, we want to simplify what we can, all right? And so what we're going to do on this top here, we want to be careful, we want to make that x positive, we're going to pull it out. So I'm going to pull out a negative 6 and just rewrite it. So that gives me a positive x minus 2. Now when I look at it, I got to determine, is there anything that I can factor now? That I can reduce. And if I look, I can reduce the 6 and the 3 by 3 and leave the 2 up here. So this answer will be negative 2 x minus 2 in the numerator, divided by x times x minus 3. Okay, again, I need this solution, and I need the LCD. All right, number 9, I'm going to have you do, and we'll come back and see how you did. Okay, so I got just a little bit, jump in here and make sure that your LCD is this, x minus 5, x plus 5, x plus 1. And if you notice, there's both of those, and here there's my x plus 5, but I needed that x plus 1 as well. So I'm going to multiply by what I need. I only need an x plus 1 here. So I'm going to go ahead and distribute and say 4x plus 4, okay? And then over here I have a 6 times x minus 5, so that's plus 6x minus 30. Okay, combine like terms. I have 10x minus 26. And over the LCD. And before I want to do now is I'm going to factor out a 2 on the top here and see if there's anything else that will come of it. So if I factor out a 2, I wind up with 5x minus 13. And now I got to write my LCD, which is all of those. X minus 5, x plus 5, x plus 1. And the reason, again, why I want you to state your LCD as much is because when you are working with this and you're writing LCD here, if I know up here what you've chose it to be, then I'm able to see exactly what you're doing in your work, okay?